So check it out. Before we even do the implicit differentiation, let's do it explicitly. Hold on. Let me look at other ones really quick. Okay. So I'm not going to start it implicitly. I know I said it right there. I should have reworded it. I'm going to do it explicitly first. So that just means, so I have an equation, y squared equals x. And I want to find the derivative of this, but the way we usually find it is to not have y squared, to have just y by itself. So y equals, how do I get rid of that square? Y equals the square root of x. So this is explicit because I'm telling you what y is. Y is specifically the square root of x. Now, if I tell you to take this derivative, I'm going to rewrite it first. Y equals x to the half. And I don't think anyone has any trouble with this. I'm going to write dy dx equals, and you just take the derivative of that, which is 1/2 x to the negative 1/2, which you would write it as 1 over 2 square root of x. Are we still okay? Yes. All right. So now let's do it implicit. We're not even going to give you guys formulas. We're just going to go right into it. You guys ready? All right. I'm going to try to go as slow as I can and as clear as I can. So both y and x are related by this relation, y squared equals x. And I'm just going to take the derivative right off the bat. So when you take the derivative of y squared, if it was with respect to y, the derivative would just be 2y, correct? But I'm not taking the derivative of y squared with respect to y. I'm taking the derivative of y squared with respect to x. So here's what you're going to write. You're going to write 2y, and they're going to write dy dx next to it. And then I'm going to write equals, and then I'm taking the derivative of x with respect to x. So that is just, what's the derivative of x? 1. Now, technically, remember a long time ago I told you, let's see if you remember, that that the derivative of x squared, this is a side note. The derivative of x squared dy dx is technically 2x dx dx. I don't know, and then you guys were like, what? Do you guys remember that? And then I was like, don't forget I said anything. All right, well, technically, when I took the derivative of x, it really is 1 dx dx, like I took the derivative of x with respect to x. So that's technically what I'm doing here. It's kind of like chain rule. It's kind of like saying, what's the derivative of y squared with respect to x? And it's like saying 2y, and then the derivative of the inside is y prime, which is dy dx. Do you guys kind of see that? So it's kind of like chain rule for everything now. If you want, I'm not a big fan of it. If you want, you can write y prime, but a lot of times there's a lot of confusion because sometimes there's like powers and everything, and that y prime sometimes looks like y to the first power. But it's kind of like chain rule. I'm taking the derivative of y, not with respect to y, but with respect to x, so dy dx. And if you just want to be a robot, let me tell you how to be a robot. Don't worry, I see you, miss. Anything that is not with that letter, I'm taking the derivative of this with respect to x, put dy dx, or dz dx, or whatever that letter may be. Does that make sense? So look, watch. d dx, and I'm going to write z to the third power. So is this an x? No. So then you would go 3z squared. Hey, that's not an x. dz dx. Now, technically, this is kind of like chain rule. Let me show you how it's like chain rule. Chavez, how is it like chain rule? I don't see it. Let me show you. 3, leave the inside alone, z squared, and then derivative of the inside, z prime. Well, z prime is dz dx. Do you guys see what we're doing there? All right.
Are you just doing the derivative of the y prime and then the derivative of dx?
I am doing, yes, separate. So let's do this one again, and I'll do it first with the y prime because it looks like you guys like that better. So look, I'm just rewriting it. I'm not doing anything yet, and it's kind of like chain rule for any letter. So look, derivative of y, and I have a squared there. So what do? 2, leave the inside alone, and then derivative of the inside. Well, the derivative of the inside is y prime. Do you guys see that? Equals, and then derivative of well, I guess there's nothing there. Derivative of x is just 1, And it really is dx, but that just goes down to 1, so you don't write it. Do you guys see that? So how do we usually say it? Like this. We go 2y dy dx equals 1. You can write y prime, 2y y prime, but try not to. Try to do this one, because I know some of you guys are going to like the y prime better. Yes?
So technically, for like the explicit one, I don't know if this is right, but we sort of like moved it around.
Yeah, you got y by itself. Now the next question is, are they the same? So right now, remember how it says solve for dy dx? Well, I have dy dx here. Now it turns to algebra. I don't want dy dx, 2y dy dx. I just want dy dx by itself. So what do I got to do to get dy dx by itself? Divide by 2y. Perfect. There's your algebra. So dy dx equals 1 over 2y. Now the next question you ask yourself is, are these the same? Are these the same?
I feel like they are, but they don't look like it.
Okay, they are the same. Why are they the same? Check it out. Look right here. I guess let me rewrite it right here. Y equals square root of x. Look at this right here. Y equals square root of x. I can replace that square root of x with a what? With a y. 1 over. So are they the same? Yes, they're the same. Because I replaced the square root of x with y. Because that's what y equals. Y equals the square root of x. Cool or not cool? So, it doesn't matter what route you go, you will get the same answer. Cool? Now, it does matter. Well, okay, it doesn't matter. For questions like this, it doesn't matter because maybe you want to solve for y first and then take the derivative. But you don't have to, guys. You can just do it implicitly right off the bat. So, look, let's go to the next question. I think implicit, once you really get the hang of it. I mean, they're both the same, really. Hopefully you know that x squared plus y squared equals 25 is a circle with a radius of 5, but if you don't know, that's fine. This is the equation of a circle centered at the origin, right? Okay. Yeah, the equation of a circle centered at the origin is this, guys. That's the equation of a circle centered at the origin. And they go, find the slope of the circle x squared plus y squared equals 25 at the point 3, negative 4. Should we do it the old way and then do it the new way, or do you want me to do it the new way first? Okay, which way do I want to do it? Do I want me to do it first? Explicit? Okay. So the way you guys would do it old school would be to move the x squared to the other side. So y squared equals 25 minus x squared. And then take the square root. Y equals plus minus square root 25 minus x squared. Now remember, the positive one gives you the top half. And then the negative one, I guess I'm going to color code it, put it in blue, gives you the bottom half. Right? Now, this point, 3, negative 4, is going to be somewhere down here. So I want the negative one. Do you guys see what I'm talking about? Okay. So here we go. Y equals, I'm going to put a negative in the front, 25 minus x squared to the half. Have I confused anyone? Have I confused anyone, guys? Okay. Why did I put the negative in the front, guys? Because I wanted the blue curve, right? Okay, perfect. So here we go. I'm finding my slope. How do I find slope? Derivative. dy dx, or you can say y prime, equals the negative half. I'm doing chain rule. Parenthesis, 25 minus x squared. Close it to the negative half. Am I done? Times derivative of the inside. Perfect. Negative 2x. Negative times the negative is a, so let's see, the 2's cancel out with the half. So I see x over the square root of 25 minus x squared. What x value am I going to insert so I can find my slope? Yeah, so I'm going to write dy dx at x equals 3 equals 3 divided by square root of 25 minus 3 squared. 25 minus 9 is 16, so this is going to be 3/4. So my slope is 3/4. That makes sense. It looks like I have a positive slope right at 3, negative 4. Are we still okay, guys? That's how you would do it the old way. Do I still got space? Yeah, I do. You guys want me to change colors? Okay. Now let's do it. How am I going to do this? Implicit. So here it is in implicit. So the equation is x squared plus y squared equals 25. And I want the slope at 3 comma negative 4. I'm going to take the derivative implicitly. Since I want the derivative, what specific derivative do I want? dy dx. Let this give you a hint. I'm taking derivative with respect to x. X squared. What's the derivative of x squared with respect to x? 2x plus, now I'm taking the derivative of y squared. Is that an x? No. So what's the derivative of y squared with respect to x? 2y dy dx. Perfect. It's not an x, so you say dy dx immediately after. Equals 25. That's a constant. What's the derivative of that? 0. Now you are done. The rest is algebra. Move the 2x to the right. 2y dy dx equals negative 2x. And then how do I get dy dx by itself? Divide by 2y, divide by 2y. If you want to cancel out the 2's, go for it. Dy dx is equal to a negative x over y. Finally, dy dx, plug in your point 3 comma negative 4. Negative 3 divided by negative 4 gives you, oh look, the same answer.
Okay, got it. So you just do each section of the original equation. You use the derivative of it with respect to x.
Yes. How do we feel?
Could you go over one more time?
Yeah.
Like you're in the, where did dy dx come from again?
Yes. I took the derivative of y squared. Is y squared an x?
Is y squared an x?
No. So as soon as you take the derivative of something that's not an x, put the dy dx next to it. Derivative of y squared, 2y, dy dx.
Thank you.
What's up, Arisbe?
So on the first one, the reason why you put the dy dx and the x is because you only had like the x.
I only had x's in there, but it would not be with the graders count points off if you did a ordered pair. No, but you don't have a y value, so there's no y value for me to enter. I mean, I guess technically the square root of 25 minus 3 squared is your y, because it tells me here that y is the negative square root of that. But you know, I mean, technically, yeah. See, you can see how they're related. We got the same answer no matter how. Now, I personally like the second better. See how implicit just looks like really fast? I think implicit is faster. And when we do related rates, you guys are going to be so fast.
Like, I guess if you like understand it, you can go pretty like simple.
It's not bad. We're going to do a whole bunch of problems. We're not going to just throw you to the wolves. Go to the next example. I tried to do my own circuit, guys. I don't know. We'll see in a little bit if I failed or not. I didn't have a lot of time like I wanted to, so we'll see. All right, here we go. It says, show that the slope dy dx is defined at every point on the graph 2y equals x squared plus sine y. Okay, so let's talk real quick, guys, about what it means to be defined everywhere. So I'm going to find an expression. If the expression is a polynomial, you're defined for every x and y. If the expression is a rational, I got to make sure that my denominator is never 0. Does that make sense? Okay, so that's all it means. So we just got to find to see how the expression looks and to see if there are any restrictions that would cause that expression to be undefined. Does that make sense, guys?
So first we have to find the slope of dy dx.
Perfect. First, we got to find dy dx. So I'm taking the derivative, and I see that I have 2y here, and I have sine y. It is not possible to get this to be y equals something. Or maybe, let me see. Nope. Because then you'd have an inverse with a lean. Nope, not possible. You have to do it implicitly. There is no other option. So here we go. What's the derivative of 2y? 2. And then what do I put next to it? Was that an x? dy dx. Equals, what's the derivative of x squared? 2x. And if you want, you can put dx, but you don't have to.
Oh, because that was just answer.
Yeah. See, we took the derivative of x with respect to x, dx, dx. See?
We know that it's with respect to x because that's the
Oh, because they told us like that we want to find dy dx, so we're taking the derivative of everything with respect to x.
and can you explain the sine y part really quick?
The sine y?
What you just said. Or I know about the things.
Oh yeah, I said if I were to try to do this, like there's no way that I can get y by itself, because like see how I have sine y? Like you can get sine y by itself here by doing inverse sine, but then what are you going to do to the 2y? Like you can't take, you know what I mean? So this you cannot do algebra. Like you have to do it implicitly. You can't get y equals something.
Wait, so you're just not gonna like write the sine y?
So I'm just gonna take the derivative immediately. So I'm not gonna write like y equals anything. I'm just gonna take the derivative right off the bat. Yes.
Could you ever be at, like, could it ever be like the derivative of something that isn't dy dx? Like,
Yeah. The derivative of z, dz dx.
but would it be? Is there anything where it wouldn't be over dx? Like it wouldn't be.
Yeah. Take the derivative with respect to time. So it'd be something dx dt, motion. Well, something has to be moving with respect to something, or it has to be a relation with respect to, like there has to be a connection, right? We're not just gonna go blindly.
Like dy dt. I don't know.
We could take the derivative of everything with respect to t.
Okay.
So then
Then you would have
there would be 2 dy dt equals 2x dx dt. If we were to take the derivative with respect to t, right? Okay. Everyone okay, guys? I haven't found my derivative yet. I still got to work with the, yeah, what's the derivative of sine y? Cosine y. And then chain rule times derivative of the inside is 1 dy dx. The derivative of y is 1 dy dx, or just y dy dx.
So
Oh.
we're only putting the dy dx when it's not with respect to the x.
Yes. If it's not an x, dy dx. Well, if it's a y, dy dx. If it's a z, dz dx. If it's a g, dg dx. Right? Yeah. We only have two letters. It's either x or y. So anytime it's a y, the derivative of y, what does y prime mean? Y prime is dy dx. Okay.
So we don't write plus 1 dy dx.
You can.
Or it's times.
Well, times, yeah. You can write times 1 dy dx. But 1 times anything is itself. So it's like saying 2x and then dx dx. Like you can if you want, but are we okay so far? All right. That's it. You are done with calculus. The rest is algebra. Your algebra skills will be getting better. Everyone's algebra skills gets better with this because look, now what we want to do is get dy dx by itself. So I'm going to move this to the left. So we're going to have 2 dy dx minus cosine y dy dx equals 2x. And now you're going to factor a dy dx out. Dy dx, open parenthesis, 2 minus cosine y, close parenthesis, equals 2x. And then to get dy dx by itself, you're going to divide by 2 minus cosine y. So dy dx equals 2x over 2 minus cosine y. And then we notice that no matter what we insert for y, will cosine y ever be 2? No. So dy dx is always defined. So I'm going to write since cosine y, let me write it better. Since cosine y will never equal 2, comma, dy dx is defined for all reals.
Because cosine only goes between 1 and negative 1.
Yeah.
There. Since cosine y will never equal 2, dy dx is defined for all real numbers in x and y. since this function has two variables, x and y. All real numbers in x, all real numbers in y. No value will make this undefined.
Wait, so that's like the 10 to the minus 1?
Yeah, that's it. dy dx equals that. Are we okay, guys? Okay. Let's keep going. Let's see if we got anything interesting. This is an ellipse. For now, it's okay if you don't, well, it's not, but we have no choice. This is an ellipse. If we don't recognize it, that's fine. We'll probably let you know what's an ellipse and what is not. You guys have been really hammered with the pandemic. So you guys got cheated of Algebra 2, and then your pre-cal, not that the pre-cal we did was fake, it was real pre-cal, but we didn't finish all of pre-cal. So we didn't get to conics in pre-cal, and you didn't do conics in Algebra 2, so you guys are not in bad shape, but, you know. Yeah, so we'll when we get to it, look, we're already here. When we get to it, we'll see if we can do mini reviews here and there. So this is an ellipse. And it says, find the tangent and normal to the ellipse at the point -1, 2. So anytime I want a tangent and a normal, anytime I want a tangent, I need two things. What and what? Point and slope. I already got the point. Now I need the slope, the derivative. So by slope, I mean dy dx. Yes or no? So do not try to get this into y equals anything. You probably can, but do not try it. Just take the derivative right off the bat, implicitly. So we're taking the derivative with respect to what letter? X. So what's the derivative of x squared? 2x. And then here, you're going to make a choice. It doesn't matter how you do it, guys. You can either group the negative with the x, or you can do this. You can go minus, and you can say, I'm just going to do the xy by itself like so. Whatever you think is easiest. Cool or not cool? What rule am I going to use here? Product. First, times the derivative of the second. The derivative of y is just dy dx, plus second times the derivative of the first, which the derivative of x is just 1, or dx dx, that's fine. Close my bracket. If you wanted to group the negative with the x, that's fine. You don't have to distribute. Plus, what's the derivative of y squared? 2y dy dx. If it's not an x, put dy dx. Equals, what's the derivative of 7? 0. You are done with calculus. The rest is algebra. The rest is algebra, guys. So here it is. 2x, I'm distributing the negative, minus x dy dx, minus y, plus 2y dy dx, equals 0. Anything that has a dy dx, I want it in the front, on the left-hand side. Anything that does not, move it to the right. Now, I'm going to move the 2y dy dx to the front, guys, because I like to start with a positive expression. So I'm going to write 2y dy dx minus x dy dx equals, let's see, y minus 2x. Does everyone know where I got that? All right, next I'm going to what? Factor out of dy dx. 2y minus x close equals y minus 2x. Next, how do I get dy dx by itself? Perfect. So now you're going to have dy dx equals y minus 2x over 2y minus x. Do not cancel anything out. Nothing cancels out. Nothing cancels out. So don't even think about it. So there it is. Now I want my slope. So let me see. Do I have white space over there? I do. I'm going to write dy dx evaluated at the point -1, 2 is equal to, let's see, 2 minus 2 times -1 over 2 times 2 minus -1. So I get 2 plus 2, 4, and let me know if I make mistakes, because I make mistakes all the time. 4 plus 2, 5. I get 4/5. 4 plus 1, sorry. 5. Did you guys get 4/5? Yes. All right. So here's my tangent. And don't worry, in a little bit with Desmos, we're going to see this beautiful graph. This is an ellipse. Like, I kind of see it angled a little bit. All right. Y equals, let's see, y minus 2 equals 4/5. X minus a -1, so plus 1. I will leave it alone. I wouldn't bother. Tangent. let's see how this graph looks. Do-do-do. Desmos. Graphing calculator. Give me the equation, guys. X squared minus xy equals what? 7. Yeah, there it is, angled. And then give me my tangent. Because of the minus xy. Because of the minus xy. Don't worry, it comes like. All right. What is the y minus 2? Yeah, you're good. Equals 4/5 x plus 1. Beautiful. Look at that. At the point, what was my point again? Negative 1, 2. Negative 1, comma 2. Beautiful. Beautiful, beautiful, beautiful. Look at that. It's beautiful, guys. I think it looks awesome. Now, can we get our normal? Yeah, let's go ahead and plug our normal here. Y minus 2 equals negative 5/4. Perfect. Open parenthesis, x plus 1. And look at that. That definitely looks like a tangent and a normal. Look at that, guys. Cool or what? I think it looks really cool. Imagine this is the orbital path of some meteor around the moon, or I don't know, around something, and then you can find this tangent as normal. Or all right. Anyways, let's go to the next one. Ooh, this one might require a lot of algebra. All right, we're about to test your algebra here, guys. You guys ready? So with this one, maybe it is, let's see. Let's not use on this one. I'm going to use y prime for dy dx, so it won't get so nasty, you know. So here we go. Yeah, it wants a second derivative, right? So y prime prime.
Okay. But first we have to do the first.
Yeah, first you got to do the first derivative. What's the derivative of 2x cubed?
6x squared.
Perfect. Minus, what's the derivative of 3y squared? Dy dx. I'm going to use y prime for this one, just in case. The derivative of 8, 0. I don't see any powers on the y, so I'm going to use it for now.
If it was like y to the third, where would you put the square?
If it was y to the third, then I would have 6y squared, and then still y prime. But if I had a power, I would probably just use dy dx. Because sometimes these look like ones. It's always going to be y prime, dy dx.
6y squared, not 6y dx squared.
If this were to the third, well, it would have been 9y squared. 9y squared, y prime. It's so because it's not, because as soon as you put a square for your y prime, that's like, what is that? You know?
And then you're just gonna, like if it was like 3y4, you created 27y.
Yeah, 3y4, 4 times 12y to the third. Yeah, y prime. Or if the y prime is bothering you, I can go to dy dx. Okay. I don't like the y prime either. All right, here we go. I'm gonna, yeah, because of the 1. The prime looks like a 1. Move the 6x squared to the other side. Negative 6y dy dx equals negative 6x squared. And I'm going to divide by negative 6y. So it looks like I'm going to have dy dx equals x squared over y. Are we still okay? Okay, now what rule do I got to use when I take my derivative again? Quotient. So here we go. Do not write second derivative. Just write, well, I guess you can here now. You can write it like this. Second derivative equals, because it's already on the left-hand side. That's already y prime, so now you can't say y prime prime. It's like if I have y prime equals, y prime prime equals, you know. Okay. All right, here we go. Second derivative is bottom times derivative of the top. What's the derivative of x squared? Plus or minus? Minus top times derivative of the bottom. The derivative of the bottom is going to be dy dx. And in a little bit, we'll substitute what that is. All over bottom squared. Are we still okay? Okay. Remember that dy dx is x squared over y. So we're going to plug that in. So here we go. D squared y over dx squared equals 2xy minus, and I guess for now, I'm going to go ahead and just substitute it first. And now, let's see, 2xy minus x squared times x squared, x to the fourth. More than likely, you're not going to have that answer. Not like that. If it were a free response, can you leave it like that? Yeah, you can. I don't think they're going to be happy, but that's fine. All right, now comes algebra. I want to get a y in the bottom of the numerator, if that makes sense, so I can subtract these. So if I put a y down here, I got to turn this y up here into a squared. Cool or not cool? So now I have this. Now I can bring that y squared up, and I have second derivative is equal to 2xy squared minus x to the fourth over y cubed. And there it is. I think that's our answer. Trying to see if we can simplify. Oh, I have a y squared on the bottom, so y squared times y is y cubed. The keep change flip. Y squared and then the y. You know what I mean? A over B over C is A over BC. I multiplied that by y over y to get a y in the denominator of the numerator. What other questions, guys? If they give it, yes. Look at this one. Last question. Now that we have experience with taking second derivatives, this one's going to be fun. You guys ready? No, look, they already tell us, they're already saving us some work. They already tell us what the first derivative is. dy dx is 1 plus sine y, so they want the second derivative. So here we go. Second derivative is equal to, what's the derivative of sine? Cosine y, and then times, yeah, that's it. And now we plug in what dy dx is. What was dy dx? Yeah, so I'm going to write d squared y over dx squared equals cosine y times 1 plus sine y. And let's go ahead and distribute that. So it looks like it's just cosine y plus cosine y sine y. Oh, that one wasn't hard at all. I was expecting it to be more algebraic, because they usually are. Which one is this one? Letter E. Yeah, that one wasn't tough at all. Lame. How do we feel?